The Hubble telescope has done it again. The Hubble telescope has managed to catch something rather remarkable. The final screams of a dying star have been seen and captured on image thanks to the Hubble telescope. A series of hauntingly beautiful images have been preserved in the last screams of a dying star and are slowly reverberating throughout the universe. The flash of light that followed a massive star-going supernova in 2016 and spread outward for more than 5 years has been captured in stunning detail by the Hubble Space Telescope. A good everyday analogy is to imagine the end of a fireworks show when the bright burst of light from a shell will light up the smoke from earlier shells that are still lingering in the area. The resulting animation of stitched-together images is a treasure trove of information about the evolution of dying stars and the dust surrounding the supernova in its home galaxy, Centaurus A. You could measure all sorts of information that is not directly related to the most recent explosion that is lighting up the scene by comparing a series of photographs taken over several minutes, such as how many shells had previously exploded, how opaque the smoke from a given shell, or how quickly and in which direction the wind was blowing. The truly stunning phenomenon of light echoes can only be appreciated from afar. They happen when something emits a flash of light that reaches the rest of the universe. That light will reflect and arrive at a different time than the initial burst if it encounters a physical barrier, such as cosmic dust clouds. A light echo is pretty much the same as a sound echo. These light echoes can be used to map and comprehend space and its objects. Astronomers noticed a supernova in 2016 and repeatedly returned to Centaurus A, the host galaxy, which is more than 12 million light-years away, to see if they could observe changes over time. The effort put in paid off. They were able to capture its light echoes as well as data on the supernova's waning light, which they dubbed SN 2016 Edge. According to astronomer Luis Galbani of the Institute of Space Sciences in Spain, the blast wave from this powerful supernova explosion is racing outwards at over 10,000 kilometers, more than 6,200 miles, per second. The intense flash of light that the supernova emits in front of this blast wave is what is causing the expanding rings that can be seen in the images. Since these cosmic explosions produce a lot of the heavy elements that make up our galaxy, stars, and the planet, supernovae are interesting. Centaurus A is a little out of place. It is categorized as an elliptical galaxy, which typically has a smooth oval shape, very few stars, and very little dust. Centaurus A, on the other hand, is dusty, crammed with star formation, and kind of warped. All of these are the traces of a recent cosmic collision with another galaxy, whose effects have not yet settled. Numerous dust clouds are thought to have been encountered by the supernova's light as it approached Earth. This would appear to be a series of expanding rings from our vantage point. During the 5-year observation period, 4 distinct light echoes were observed, or 4 dust clouds, each of which was large enough and dense enough to produce a light echo. The researchers, led by astronomer Maximilian Stritzinger of Aarhus University in Denmark, were able to map the dust surrounding the supernova thanks to these light echoes. According to their analysis, the dusty structures have spaces filled with a material that doesn't have enough density to make a light echo that can be seen. Even though we are pretty excited to see an image of Centaurus A from JWST, which will cut through the dust to reveal the mysterious heart of the galaxy, the research reveals that Hubble still dominates some observations. Since Hubble has been in space for decades, it has been able to record long-term observation that reveals the structure of another galaxy in great detail. We were able to create very impressive colored images and animations that show how the light echoes have changed over 5 years thanks to the remarkable dataset. It has only been found in a handful of other supernovae, making it a rare phenomenon. Well, that's it for today. If you enjoyed the video, please hit the like button. If you have any suggestions, leave them in the comments section. And if you enjoy our content, and never want to miss a video, hit the subscribe button. Thank you for watching.